So in this problem, we have two objects that are about to collide, and one object number one would have an initial velocity of positive 5 meters per second, meaning it's moving to the right, while the second object is moving to the left with a rate of negative 3 meters per second. The mass of the first object is 2,000 kilogram, second one is 6,000 kilogram. After collision, the mass is conserved, so meaning there's no changes in masses. So first object still will remain 2,000 kilogram, while the second object is 6,000 kilogram. However, after collision, the second object is now moving towards the opposite direction, meaning from negative to positive 0.95 meters per second. So first thing that we want to figure out is the final velocity of the first object, or the 2,000 kilogram object. And second, we want to figure out whether this collision is elastic or inelastic. So let's figure out elastic or inelastic. So these are the two questions we have to answer today. And so before we answer that question, why don't we solve for the initial velocity first? And what is the most practical way of solving it is by applying the law of conservation of momentum, which means that the initial velocity multiplied by the mass of the first object is plus the mass of the second object multiplied by the initial velocity of the second object is equal to the sum of the momentum on both sides after collision. So let's start by plugging in the values of 2000, positive 5 for the first object, plus for the second object it's 6,000, multiplied by negative 3 for its velocity before the collision. And after collision, we have 2000. Since we don't know the velocity of the first object afterwards, let's keep it as v sub f uppercase plus 6,000 multiplied by 0.95 meters per second. Okay, again, so we can keep it simple for every one of us by dividing all of the terms by the greatest number that we can divide it by, and that is 2000, since 2000 is common to all of them. So 2000 divided by 2000, so meaning that is 1 multiplied by 5 plus 6,000 divided by 2000, so that's 3 multiplied by negative 3 is equivalent to 1 times Vf plus 3 multiplied by 0.95. So simplifying this further, we have 5, 3 times 3, or 3 times negative 3 is 9. That is negative 9. So we have V sub f plus 3 times 0.95 is simply 2.85 kilogram meters per second. So let's simplify the left side and then move 2.85 to the other side of the equation. So this will give us negative, since negative is greater than positive. So this will be negative 5, 9 minus 5, so that is negative 4, is equivalent to V sub f plus 2.85. So I want to get rid of my 2.85 on the right side and move it to the other side. So all I have to do is subtract 2.85 both sides of the equation. Negative 2.85 cancels out. So we have the value of negative 6.85, and that is our VF. So meaning the final velocity is negative 6.85 meters per second. So now the question is this elastic or inelastic? So before we can answer that question, what are some of the two conditions that we must know during collision? Is the momentum conserved? So that's the first question we must answer. Momentum is conserved. or the total momentum is conserved. The second checkbox is the kinetic energy conserved, meaning it's not destroyed, but rather it was just converted to another form of energy. So momentum is conserved. So why don't we plug in using the first equation that we were using, and that is the law of conservation of momentum. V sub I plus mv sub I is equivalent to mv sub f plus mv of f. So that is 2000 multiplied by 5 plus 6000 times negative 3. Is it equal to 2000 multiplied by negative 6.85 plus 6000 times 0.95. Again, make it simple. Divide all of them by 2000. So this will give us 1 times 5 plus 3 times negative 3. Is it equal to 1 times negative 6.85 plus 3 times 0.95? They're going to be equal. That is the question. Okay, so that is the question. So what is 5 times 1 times 5? So that's 5. 3 times 3, negative, so that's negative 3. Is it equal to negative, negative 6.85 plus 3 times 0.95 is 2.85. So what is 5 minus 3? And that will give you, so that's not 3. 3 times 3 is 9. Sorry for that. And that is negative 4. How about on the other side? 6 is greater than 2. So that is negative 4. So meaning negative 4 and negative 4 are equal. So the momentum is definitely conserved. Okay. Now, what do we know about kinetic energy, about conservation of momentum? Every time there is a collision, momentum is always conserved. So now let's move on to the next process, and that is to figure out if the kinetic energy is conserved or not. So let's find out if the kinetic energy is conserved or not. Okay, so let's solve it. The equation is 1/2 mvi squared plus, let me just move it up so you can see it. Let's just put it on top of each other so you can see. Plus 1/2 mvi squared, which is equivalent to 1/2 mvf squared. It's 1/2 mvf squared. Okay, to get rid of those 1/2, let's just multiply both sides of the equation by 2. 1/2 cancels on both sides. Cancel it out. So plug in 2000 times, what is your v sub I? And that is 5 squared plus mass of 6000 times negative 3 squared, 2000 multiplied by negative 6.85 squared plus 6000 times 0.95 squared. Again, let us all divide both sides by 2000 to eliminate to reduce the process of multiplying numbers with a lot of zeros. So we have 1 times 5 square. So I think we can move this one on this side. Okay, so now you can see it. Plus 3 times negative 3 square. Is it equivalent to 1 times negative 6.85 square plus 3 times 0.95 square. So this is 25. So this one is 9 times 3. So that is plus 27. Okay, so plus 27. Is it equal to, what is negative 6.8? Let me just use the calculator quickly. 6.85 square is 46. So this one is 46.9, or I can just say this is approximately 47. And then plus, what is 3 times 0.95 square times 3. So this will give us 2.7. 2.7. 6.85 times 6.85. So this will give us 0.95 times 3. Alright, so let me just calculate this one. 0.95 square times 3. So that is 2.7. Are they equal? So 27, so that's 2. 5, so that's 52. How about this 2 over here? So that's zero point 0.7. 2 plus 7 is 9. 49.7. So it means that they're not equal. Going back to our checklist. So meaning kinetic energy is not conserved. So now how do we know which one is which? Let's use a different pen. Elastic. When we say a collision is elastic, inelastic. Momentum is conserved. Momentum and kinetic energy, both of them are conserved. Inelastic, meaning momentum is conserved, and kinetic energy, no. So energy was not destroyed, but instead it was transformed to another form. So looking at our checklist earlier, so you could see both sides. You notice that momentum is conserved, kinetic energy is not conserved. So definitely it's not the elastic collision, but instead we are looking at an inelastic collision. So it means the two objects touch during collision, but they failed to connect. So we can say that the collision is inelastic. What is your evidence? The kinetic energy are not conserved, and the momentum is conserved. And that is the description of an inelastic collision.